Choosing the right storage solution in Azure can make or break your architecture. Today, what we're doing is we're breaking down the major Azure storage services: blobs, tables, queues, and files, with real-world examples and C# demo code. Let's dive in. Let's start from the beginning. Azure is a cloud platform. It offers many services, and one of such is Azure Storage. It's a purpose-built storage solution for nearly every scenario. Whether you're handling massive image uploads, managing metadata, or queuing background jobs. We'll go over what each one is best at and where they might fall short. Blob Storage is your go-to for unstructured data. Think files, images, backups, logs. It's cost-effective and scalable and supports 3 blob types: block blobs, which is great for general purpose file storage; append blobs tailored for log data; and page blobs, which is good for fast read-write on fixed size blobs like virtual disks. To use your storage account for blobs, you need to navigate to the containers area here and add a container. A container is simply a logical classification of how you group them, just like you create folders on your computer. So you need to go ahead and say, let's call this Azure Storage Demo. We could create this via code also, but that is one thing to note. You can create it here. And because anonymous access is disabled on the storage account, to access blobs, we'll need to first go disable that, just in case we are exposing the files that we store here publicly. But the purpose of this demo, I would not be exposing that, but it's something you can go ahead to the properties area, configuration area here, and change that. All right, you can just enable that here and save that option, and you're pretty much ready to go. Now let's go back to containers area here. But before we do that, to be able to use this via code, Azure, C#, PowerShell, CLI, you name it, whatever automation tool you're using, you need to go to access keys area here and pick out a key or a connection string. This should always be secure. Yes, I'm showing this to you because I can always rotate these keys as needed. I can hide them, I can rotate them as much as I need. All right, so let's pick out the key and the connection string here. I'm just gonna open my Notepad application here and save that in there because we need to use it. Ideally, you want to store this in a safe area like Keeper, Azure Key Vault, or something. That is the key, and that is the connection string. Copy that. That is in the Notepad now. Next thing I want to do now is actually go ahead and use code to explore how this is supposed to work. So let's go ahead now and actually create an application that's going to use our storage account. So I'm going to go into my dev drive here. And I'm going to create a simple C# based application for us to be able to use this. So I'm going to do a .NET new console. I'm going to give it a name, storage demo. Just to show you that I'm doing this pretty much from scratch. And I'm going to go into my program.cs file here. And that as just a simple hello world application. So I'm going to set some variables here. Best practice is for you to actually put this in environment variables, but for the purpose of this demo, I will use the plain variables because I'm supposed to clean this up later on. So I'm going to set my variable of connection string to be, remember that variable we copied earlier on, that connection string we copied earlier on, this one right here, we paste it in, end the line, and we are pretty much ready to go to start writing the code. Another variable we need here is the container name. All right, so we've got the container name, we've got the connection string. Next step for us now is to go ahead and start putting stuff in. So let's get started. And to do this, it's pretty much simple. We need to import some usings for this application. To be able to use this properly, we will need to use the azure.storage.blobs library. So what I'm just going to do is go into my C# file right here, my CS project file, and import that. But of course, you could use the CLI to add this in right here. And this is using the storage blob nuggets package. And when I do a restore, it's going to restore and it's just going to work out of the box, just like that. Now for the blob one now, let's go ahead and start writing the service. So we're going to go say blob service client. And we now need to import the references that we just added. And then we'll also use the container client. Then if the container does not exist already, we'll create it using this code. And then set a file name for what we want to upload. Let me just put a random file in the root of this application. So I'm just going to get a random file on this computer and just slam it in the directory. Ideally, you want to put the file in from somewhere you can trust. Maybe someone is uploading, convert that to a file, and then upload. So using these two pictures for this demo right here, and then I will save first blob name. I'm just going to copy this name here. And then second blob name, I will use this one right here. You can see the auto suggestions here. That is Copilot trying to help me out, but don't worry, we will forget that one pretty soon. So let me get the path for this one because it's needed for this to work properly. So, and I'm gonna literalize it. Yeah, because this is C#. All right, literalize it if that's a word. All right, so let's get started now. Next we want to do now is create a blob client. So let's create one for the very first one. Ideally, you want to be iterating over this. So get blob client. We're giving it a new name here, but we can also use the original name. Okay, let's make some fun here. File info dot no. Yeah, we're grabbing the name, specifically just the name, not the path now for that one. And then we just go ahead and put that in a file stream. That's in the file stream now. And then we go ahead and upload. We can do the same for the second blob client also, but let us comment that out for now and test this out and see if it really works. This is a live demo here. No fuss, no pain, no gain. So let's go ahead and cd into the storage demo application here and do a .NET run. And while that is running, let's just go into the Azure portal again for a minute and see what we have. So we have the storage browser here. We have containers. You see, it's actually working. Just created at 12:42 local time here. And we have our file created. Easy peasy. So if I put it here, you see it's not been visible. That is fine. That is not allowed simply because I did not allow public access for this one. So, but the file is there. Let me generate a SAS token for this so that we can actually see it. So I'm gonna add this and blob SAS URL, and I open that ideally properly. That downloaded to the computer, and I can open it up here. Pretty nice, right? That is how file storage blob options work inside of Azure, right from inside the code. Let's try this now with the second blob file. And we're just gonna do a .NET run on this now also. And we're gonna see that magic happen just like that. Now that the blob exists already, it's just gonna go ahead and upload that file, and it's pretty much done. And that is using and uploading files to Azure Blob Storage. If you need to store massive amounts of structured non-relational data, table storage is the answer for you. It's fast, it's scalable, and it's schemaless, which makes it shine. It's perfect for metadata, IoT data, and user records without complex queries. So use table storage. Pretty much the same way we've been working with our service. I've commented every other thing out. So what we need to do is create a client for it. var service client equals new table service client, and we pass in we inject the connection string. And that needs a using operation, Azure data.tables, and it's good to go. And then we'll connect to the table, service client.getTable. That can allow capital letters, and creative does not exist. And then we'll just start creating table entities with partition keys and row keys and start getting files in. As simple as that. If I run this now, and go back into the Azure portal, and I go into my tables, I see the table right here. To be able to see it properly, actually, I click it from here and I see my partition key, my row key, and my data right in there. I can continue writing options inside the add an entity manually. I can even add more properties as I go along in my demos. So I call this demo. And the sweet thing about this one now is that the other piece of data does not actually think that the other one does not have it, which I think is pretty nice. When decoupling components or managing background processing, queue storage shines. You get reliable, ordered message delivery with minimal overhead. It's built to scale with your workloads. So we're gonna give our queue a name, and we're gonna create a queue client. To make this simple, we're gonna use the using operations. We know how this rules already, right? And creative does not exist already, and then we start putting a new queue in and start rolling. So what this piece of code does is pretty much go into the queue, go into Azure Storage, go into the queue, get a queue client, and start putting queues messages in the queue. And if we do a .NET run in here now, the queue has been created for us. If we go back into Azure and go to queues, we should see our queue. And this is the message text that was sent. It has an ID, it has a body. I've hidden all these fields. And it's pretty much ready to go for another service to consume this queue and utilize. Now, all the codes I've used for this demo is that I will clean all this up. I'll clean all these code demos up, put them in GitHub, and put it in the video description so you can download it for yourself and work with it. Pretty simple and nice. If you need a classic file share in the cloud, Azure File Storage gives you an SMB-based access with cloud flexibility. It's ideal for migrating legacy workloads or enable shared storage for modern applications. We have our connection string. What we need now is the share name. So we'll go down here and say file share name equals this. I want to create the file share client, just like we created a blob share client earlier on. So let's do that. And that is also needing a reference, a unique reference to use, and that will be imported into the CS file, just like we did for the blob one. So for the purpose of this demo, I'm just going to add every other thing I need to use as references, and I will be covered there. All I need to do now is start doing the using operations in my code. And I need to import the using called azure.files.storage. So I can either put it here using azure.storage.files.shares. And I need to bring that up to the start of the file, and that is been resolved. And create the share if it does not exist. Get the file names, and then let's get the file uploaded. And the file is now uploaded in this code. We've not tested it out yet, but hopefully it should work. All right, let's see if this works. That just ran with no information. Was it that fast? Let us see. Let's look into Azure to see what has been done for us. Let's go to file shares. And we see here, pretty much created 100 terabytes. I need to delete that ASAP. And we can browse the content of it to see our file. Now we can go ahead now and actually mount this file share to a computer, and it's pretty much ready to go. Now to save money, I don't waste time. I delete my file shares immediately after doing demos because it's pretty expensive. So that is file share, pretty much easy peasy, just works. I'm not going to even use the second file name here. The first file name is enough for us to be able to do the demo. Let's wrap up this video with a quick side-by-side comparison of every storage service we've talked about in this video. Blobs, best for media, backups, and logs. Tables, best for NoSQL data and user metadata. Queues is for asynchronous workflows and decoupled systems, and file shares are good for lift and shift and shared access. Now you've got the insights and code to choose the right Azure storage solution. Which one are you using in your projects next? Drop it in the comments. Now that you've got the insights and code to choose the right Azure solution, which one are you using in your projects? Drop them in the comments and I'll get to them and reply as soon as possible. I'll see you in the next video. Bye bye.